Welcome to Lesson 40, Simplifying and Evaluating Expressions Using the Power Properties of Exponents. We're going to be looking at a lot of different properties today of exponents, and it is sometimes difficult to keep them all straight, but one thing you can always do is just multiply or divide the actual function out, the actual whatever it's asking you to do. So we're going to start with that. Well, actually, before we begin, we'll look back at a few reminders of exponent properties. The first one is x to the 0 property. No matter what the number is, if it's to the 0 property, it always equals 1. So don't ever forget that. And x to the first power is always equal to x. We already know that. We know that when you have x to the m power over x to the n power, if they have the same base, then you subtract the exponents, and then right below that, if they have the same base and you're multiplying, then you add the exponents. And then the last two are the negative exponent properties. So if you have x to a negative exponent, you just flip that exponent and its base down to the opposite side of the fraction. So in the first example here, if it's in the numerator, then you would flip it down to the denominator. And if it's in the denominator to begin with, then you'd flip it up to the numerator and make it positive. So to start with today, we're going to look at a couple examples of exponents of exponents. So we have 3 to the second power to the third power. So this whole thing, everything in parentheses, 3 to the second power, is going to be multiplied 3 times because 3 is the exponent there. So we already know from our properties up above that if we're multiplying exponents of the same base, which they all have the base of 3, then we add the exponents. So we would have 3 to the 2 plus 2 plus 2 power, which is 6. Okay, the next example, we have 4 to the 5th power squared. So we have 4 to the 5th times 4 to the 5th, which again we're going to add 5 plus 5, which would be 4 to the 10th. And the next one, 7 squared to the 4th power. So 7 squared times 7 squared times 7 squared times 7 squared, 4 times. And we add the exponents, 2, 2, 2, and 2, which is 8. So what is the pattern that we are seeing here? Hopefully you've noticed so far that we're multiplying the two exponents together. So that is the pattern. When you have an exponent of an exponent, you multiply the two exponents together. So we'd have 3 times 2, which is 6. And here we have 5 times 2, which is 10. And we have 4 times 2, which is 8. So the next few examples here are actually examples using variables. So same thing, if we have a cubed times a cubed times a cubed 5 times here, we would have a as our base still, and we would add 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. And of course, 3 times 5 equals 15. So we'll do the next example without actually writing it out. So we'd have d to the 4th power to the 4th power. So that would be 4 times 4, which is d to the 16th power. And then the last example here at the bottom, b to the 6th power squared would be b to the 6th power times b to the 6th power, which equals b to the 12th power. And 6 times 2 is, of course, 12. So at the bottom there, I'm going to move on to the next screen here. What is the rule? I have put this box here for you to fill in the rule, the power of a power property. So So in this box here, if m and n are real numbers and x does not equal 0, so you can't have an exponent of 0, otherwise it's just 0, then we multiply m and n. So if you write in your box, fill in there, if we have x to the m power, in parentheses, to the n power, that would equal x to the m n power. So you multiply the exponents there. Okay, so a couple more examples at the bottom of the page here. 3 to the 4th squared, we would of course multiply 4 times 2, keep our base 3, and 4 times 2 is 8. And then the next example, we have a z as our base, and then 5 times 3 is 15. So very simple if you can remember the rule. Moving on to the next page, we have a couple more rules here to remember that go along with this. So the first one is, if you have two numbers inside the parentheses and the parentheses themselves are held to an exponent that's not 0, then it would equal each thing in the parentheses, each factor would be held to that power. So it would be x to the m power and y to the m power. So you can separate each thing in the parentheses. So let's look at an example of that in A here. We have 3 and then g to the 4th in parentheses. So I'm going to separate them, 3 and g to the 4th. And I'm just going to put parentheses around them so that I can keep them straight. So both of those factors are going to be held to the 3rd power, because that's this exponent outside the parentheses. So I'm going to hold both of those factors to that power. So then 3 squared would equal 3 times 3 is 9, times 3 is 27. And g to the 4th power cubed, sorry, I think I said squared before, 3 cubed is 27. Remember, we multiply their exponents, so it's g to the 12th power. So the answer would be 27g to the 12th power. Okay, let's try one more example of that. So we have our factors. We have negative 4, we have m squared, and we have n cubed. And we're going to hold all of these to the squared power. So I'm going to add a squared to all 3 of them. And then I'm going to go through and solve them. So negative 4 times negative 4 would be positive 16. And then m squared squared, we multiply 2 times 2, so m to the 4th power. And then n to the 3rd power squared, we multiply the 3 times the 2, which was n to the 6th power. The next couple examples go with the next, let's see, we already did this property. You should have filled in the box. The next property is a property, the power property of quotient, or power of a quotient property, excuse me. So we're going to fill this in. This is the same thing, but instead of multiplying in parentheses, it's division in parentheses. So you distribute the exponent so that it's x to the m power over y to the m power. So let's try a couple examples of this. So we have 5x squared on the top and 7 on the bottom, and we're going to hold both of those to the cubed power because that's our power here. So we have cubed and cubed. Okay, so now we actually have to distribute this cubed to the 2 factors in parentheses that are being multiplied. So this time we're going to use the power of a property, the power of product property, excuse me, with the cubed here. So we're going to have 5 cubed, and we're going to have x squared cubed on the top. And then we have 7 cubed on the bottom, and 7 times 7 is 49, times 7 is 343. Okay, and then on the top we have 5 cubed, so 5 times 5 is 25 times 5 is 125. And then we have x squared cubed, which would be 2 times 3, so x to the 6th power. And then we still have the 343 in the bottom. So that's our final answer for that one. Okay, moving on to the next example for D. I'm going to move to a new page here. Same thing, we're going to separate the numerator and the denominator and distribute the squared that's on the outside here. So we have negative x to the 5th power. I'm actually going to separate this to be negative 1 squared and x to the 5th power squared. And then on the bottom I'm going to have 6 squared and y squared if I distribute the squared on the bottom. So negative 1 times negative 1 is positive 1. X to the 5th squared would be x to the 10th, 5 times 2. On the bottom, 6 times 6 is 36. And then we have y squared. Now we don't actually need that 1 because 1 times x to the 10th power is x to the 10th power. So we can rewrite that like this. Alright, next example. We're going to put this all together here. So we're going to first look at this one and distribute the squared. So I have a 2 that I'm going to square, I have an x that I'm going to square, and I have a y cubed that I'm going to square. Okay, and then over here, I'm going to cube everything in this one. So I have a 5 cubed. I'm going to put a multiplication symbol between these here. And then I have x squared that I'm going to cube, and I have a y that I'm going to cube. So underneath here, I'm going to have 2 times 2 is 4, x squared. Y cubed squared would be y to the 6th power if I multiply those. And then 5 cubed is 125. And then x, I have 2 squared and cubed, so that's to the 6th, and then y to the 3rd power. Okay, now I can multiply what I have combined here. So I have 4 times 125, I'm multiplying like terms. So 4 times 125 is actually 500. And then I have x squared and x to the 6th power. So when I'm multiplying things with the same base, I have to remember my rules here. X squared times x to the 6th power. I keep my base and I add my exponents this time. I'm not going to multiply my exponents because it's not x squared to the 6th power, it's x squared times x to the 6th power. So I add them. So that's x to the 8th. And then the y's, I have y to the 6th and y to the 3rd, and again they're being multiplied. So that would be adding their exponents. So I'd have 6 plus 3, which is 9. And again, if you forget the rules, just multiply them out. So if you're asking yourself, okay, an exponent of an exponent, x squared to the 3rd power, if I'm looking at this as an example, I forgot what I'm supposed to do. Do I add the exponents or do I multiply them? Just write it out. X squared times x squared times x squared. And that will remind you that that's 2, 4, 6 x's, so x to the 6th power. Okay, we already did that down below. And then again, if you have x squared times x to the 6th power, then you can think to yourself, okay, that's how many x's? That's 2 there and 6 there, which is x to the 8th power. So if you forget what the rules, just go ahead and write them out. Okay, to save time, I have already written out the steps for f here. I have negative 4 to the 2nd power because I'm distributing this 2 on the outside of the parentheses. I have x to the negative 3rd power squared. And then over here for the 6, I have 6 cubed. I'm distributing this exponent. X cubed and y squared cubed. Okay, so negative 4 times negative 4 is 16. For an exponent of an exponent, I multiply negative 3 times 2, which is negative 6. And then over here, 6 cubed is 216. X cubed. And then y squared cubed is y to the 6th power. I multiply the exponents again. So here I need to get rid of this negative exponent by flipping it to the bottom. So it would be 16 over x to the 6th power. So now I can put a 1 under this over here and multiply my numerators and my denominators. So in the denominator, all I have is x to the 6th power. Okay, and 16 times 216 on the top, my like terms, is 3,456. And then I have my x cubed right here, and my y to the 6th power right here. So now I just need to cancel out my x's. So I have 3 on the top and 6 on the bottom, so that would these 3 would cancel 3 of these and make this x cubed on the bottom. So I'd have x cubed on the bottom, and I have 3,456 y to the 6th power on the top as my simplified answer. And that's it. Thank you for listening and taking notes.